All right, you people, welcome back to video number 3. In this video, we're going to go ahead and formally just apply the chain rule. Just to recap, the chain rule is used whenever we have a composition, whenever there's an inside-outside situation. And just to kind of show you and walk you through the symbols here, I'm looking at this formula as a chain rule. And it says, if I'm taking the derivative of a composition of functions, I take the derivative of the outside with the inside function inside there still in there, times the derivative of the inside. The derivative of the outer function with the inner function still in there times the derivative of the inside. Okay, so we had done some prep work in the previous video. We identified our inner function. Our inner function is u, and we've identified the derivative of our inner function. I actually want to start with example 4 and then go back and do example 3. Okay, we identified the inner function. Did we identify the outer function? What am I doing to this u expression, this inner function that we identified? Well, we're taking u to the third power. So my function f of x can be rewritten as u to the third as long as I know that u is this whole expression, right? The whole expression, or if I think of it this way, something to the third power, something to the third power. That's my outer function. My inner function is the something. So if I think of this as my derivative, then I can say f prime of x is the derivative of this outer function with the inside still in it. So that would be 3u to the second power times the derivative of the inside, and that would be u prime. So the rule says take the derivative of the outer function. My outer function is u, or something to the third power. The derivative of that would be 3 times something squared. But the u is still in there. That's my inside function, times the derivative of the inside function. All right, let's keep going. Can we substitute now? Because in reality, this u is that whole green expression. And so I'm going to write the whole green expression in place of u. And then my derivative of u is this whole orange expression. So I'm going to write this whole orange expression. Notice that I'm using parentheses. Since I have more than one term, I don't want to not put parentheses because then it's going to look like I'm only multiplying it times 3, but I'm multiplying times the whole derivative, which is 3 minus 4x. And just like that, we have found the derivative. The derivative the chain rule says, take the derivative of the outer function. So if I were to block all of this out and say, oh, look, I have a green rectangle. So green rectangle cubed, well, the derivative would be 3 green rectangle squared. 3 green rectangle squared times the derivative of the inside, the derivative of the green rectangle, which would be this orange thing. So over here on the side, when we did our pre-work, it kind of helped us find the derivative a little bit easier, a little bit faster. That's not so bad. Okay. Let's go back to number 3. So let's rewrite the original function, which was a composition, as just the outer function in terms of u. So according to this, we had -7. My inner function, my inside function, I called u, and u was being squared. This is my outer function, -7 over u squared. Now remember, we can't take derivatives whenever I have power functions on the denominator, so I have to rewrite it. And so this becomes -7 u to the -2. Okay, so now we're ready to take the derivative. So as I get ready to take the derivative, the chain rule says, take the derivative of the outer function. Well, this is the outer function, with the inside still in it. Well, this is the inside. So u is the inside. So I'm just going to take the derivative of this. That would be 14 u to the power of -3. But then I need to multiply by the derivative of the inside. I need to multiply by u prime. So I took the derivative of the outer function with the inside function u still in there times the derivative of the inside function. Great. Now let's replace things. That would be 14 times 2x minus 3, everything to the -3 power, times the derivative of the inside, and the derivative of the inside was 2. That should be 2x minus 3. Oh no. I was trying to make it look a little bit clearer that is 2x minus 3, and then there was a parenthesis here. That's my derivative. I got my derivative using the chain rule. Now, I still have a negative exponent, and some people are a little iffy about negative exponents, so we're going to take this negative exponent, we're going to take the reciprocal and flip it over. As I do that, I notice that I'm multiplying by 2. I'm multiplying times 14, so that's really 28 over 2x minus 3 to the third. This could be considered the final version of the derivative. Taking the derivative of a composition requires the chain rule. In order to do the chain rule, it's important that you identify the inner function and the outer function. You take the derivative of the outer function. That's all this black writing that I have, with the inside function in green still in there, times the derivative of the inside. If you just keep saying that in your head or out loud, if even, take the derivative of the outside with the inside still in it, times the derivative of the inside. You can't go wrong. We're going to do one more, and then we'll pause this video. We'll come back with some more examples. If you need more examples, you can watch the rest of it, the video that comes after this one. I kind of like this one. Example 5. I like that one and example 7. So on the next video, we'll do example 7. But example 5 says, sine of 4x minus 1. This is already my inside function, so I'm going to rewrite it as sine of, not 4x minus 1, but I call that u. That's what g of x is. G of x is sine of u, where u is 4x minus 1. Now we're going to take the derivative. The derivative of this would be the derivative of sine, which is cosine, with the inside still in it, times the derivative of the inside. Okay. Now let's put everything back in terms of x. That would be cosine of 4x. Let me do that in green. 4x minus 1 times, and I'll do this one in orange, 4. Again, I don't think, I can't multiply 4 in here because this whole thing is inside of cosine, right? But I can put the 4 in the front, and I can just say this is 4 cosine of 4x minus 1. And just like that, we've done the chain rule fairly easily by identifying inner function, outer function, taking the derivative of the outside function with the inside still in it, times the derivative of the inside. And that is the chain rule.